dimensional analysis, whatever you call this, it's the same idea. What we're doing is we're converting between units. Now I'm going to start just by showing you what I mean by this and how it works. So let's say I have a measurement, it's 12.4 centimeters, and I want to know how many meters that is. Well, the simple way is to just do the kind of moving the decimal place thing, right? Figure out how many decimal places you have to move, and you can memorize that, right, with the metric system and figure out how many you have to move. And that's fine, and if you're just doing one-step conversion like this, I'd have no problem with that. But let me show you how to use what we call the factor label method. I start by writing down the equivalency that I need, which is the relationship between centimeters and meters. So I know that there are 100 centimeters in 1 meter. And that's on that sheet that I put up on the website. And if you haven't memorized that sort of thing, you should. Now I realize that I can express this as a ratio, right? It's an equality, but it can be expressed as a ratio. In other words, I could write it like this, in this form if I wanted. There's a relationship. It is 100 centimeters for every 1 meter, okay? And I can write it like this. I can write it in either of those ways. Now, the interesting thing about these is that these fractions, they don't equal 1 numerically, right? So the first fraction here, 100 centimeters over 1 meter, equals 100 numerically. The second one equals 0.01 numerically. But in terms of the quantities that are actually on there, so if you think in terms of what's really represented by the numerator and denominator, then in that sense, these fractions are unity. They equal 1. What I mean is, what's on the top is equal to what's on the bottom. It's the same thing. So just like when we multiply something by the number 1, we don't change the quantity, right? It works the same here. If I take 12.4 centimeters and I multiply it by this fraction, I'm going to change it numerically because I'm dividing by 100. So I'm going to get 0.124. But I'm not changing the quantity. Why? Because the numerator and denominator in this fraction were equal. They're the same length. And so I'm not changing the length of this thing by multiplying by that fraction. I'm only changing its units, which is what I wanted to change, which is what this is all about, is just changing the units of things. Now, notice how I wrote meters on the side here. And what we do in the factor label method is we basically set up the conversion. We start by identifying the potential conversion factors that we can use. And then we figure out how to arrange them so that we can cancel out the units we don't want and leave the units we want. Now, you notice I just crossed out the 2 centimeters. Why? Because when you divide something by itself, it cancels out. Right? You remember that from algebra. Divide something by itself, it cancels out. So if you've got 1a over 2a, the answer doesn't have an a in it. Follow me? 1x over 2x, the x goes away. Same thing here. This is 12.4 centimeters times 1 meter over 100 centimeters. The centimeters disappears. And so this is why I like the factor label method name, because it's kind of like we're treating labels as factors in the equation. We're treating the unit labels as factors. Now you have to be a little careful though with that. Those units, the centimeters and meter, they are not variables. So I just use the A and the X as analogies. It's really not analogous because there's never a time when you're going to be plugging a number in where that CM is. You follow me? They are not variables. They're units. They're labels. Okay? But we're going to treat them as if they're factors in the sense that we can cancel them out. We multiply them together too. Like when you have meters times meters, the answer is meters squared, right? You're treating the units as if they're factors. But they are not variables. And I emphasize that, and we'll run into that again in the future. It's easy to confuse them for variables and to start to think, wait, I need to put a number in there as if that were an X that I needed to fill in. You follow me? Don't do that. This equation is done. All you need to do is plug in the numbers 12.4 and 100. So that's the essence of the factor label method. And what I'm going to do is, and we'll finish this tomorrow, I guess.